Oh, hi! I didn't see you there. My name's Chef Dodge, and welcome to Cooking with Einsteins. Today, we'll be cooking fudgy brownies. Let me introduce to you my sous chefs for the day.
Hi, my name's Ian Rudiger, and today I will be talking about leavening in the brownies.
Hi, I'm Zoe Gondring, and today I'll be talking about food structure.
Oh. Hi, I'm Mackenzie, and today I'll be talking about the pan we're cooking the brownies in.
Yeah.
So we are now going to set the oven temperature to 225.
We're gonna oil the pan. Oh. We're gonna oil the pan.
So, the first step to making delicious chewy brownies is 1 1/4 cup of cake flour. Then we will add 3/4 teaspoon of baking powder. Then we will add 1/2 teaspoon of salt. The reason we use baking powder when cooking brownies is it acts as a leaven in order to rise as it's in the oven. In 1791, French chemist Nicolas Leblanc produced sodium carbonate, also known as soda ash. This was later known to be called baking soda. Baking powder now has a combination of baking soda and a reactant acid. Now, baking powder, a combination, consists of baking soda, sodium hydrogen carbonate, and dry acid, sodium aluminum sulfate. When a liquid substance is added to this, it creates bubbles of carbon dioxide, also known as CO2. And there are types of baking powder: single acting and double acting. Single acting creates CO2 bubbles directly when it's baked, but you have to bake your dish directly after mixing. And double acting baking powder allows you to wait before baking, and it produces small amounts of CO2 directly, and then large amounts of CO2 later, allowing the substance to rise in the dough.
On 6 ounces of baking unsweetened chocolate with 12 tablespoons of unsalted butter. 3.
The structure of multi-ingredient foods may affect the way we chew and break down certain products, like these brownies. The structure of food consists of carbohydrates, fats, and proteins. There are 4 types of protein structures: primary, tertiary, secondary, and quaternary, and are also made up of hydrogen, nitrogen, and oxygen. And in the brownies, the protein comes from the chocolate. Fats contain the most energy per gram in the foods that we eat, and the fatty acids ensure sufficient energy and nutrient intake. And we get our fats from the butter. Looks pretty good in there. And then finally, we have carbohydrates, and these are made up of carbon, hydrogen, and oxygen. Carbohydrates add on to the taste and appearance of your foods, and they are what make your food taste so delicious, like the sugar.
Hi, my name is Chef Dodge, and I'll be your host for one of the 4 concepts we will be talking about today: heat transfer. There are 3 different types of heat transfer you may have heard of before: radiation, convection, and last, but certainly not least, conduction. And guess what? All 3 types of heat transfer are involved in the production of these delicious brownies. So we'll be talking about them in relation to baking. First, we'll talk about radiation. When baking these brownies, energy from the inside of the stove is given off in it, as well as around it. That is why if you've ever gone near your stove while it's on, you feel heat radiating from it. Did you know that radioactive materials are made up of atoms that are unstable at first, but when they become stable, they release excess energy called radiation? Alright, let's talk convection now. This is when the air surrounding the heat source, in this case, the stove, collects lots of energy, and the molecules begin to move away from one another, causing them to rise, resulting in cool air rising. Here's another fun fact. Convection helps make this Earth livable by removing excess heat from the Earth's surface. Cool, right? And finally, drum roll, please. Yeah. Conduction. This takes place when the brownies are being baked. Because the outsides of the brownies are closer to the heat being radiated from the stove, they cook faster, causing the famously delicious, chewy on the inside, crunchy on the outside brownies. And here's one last fun fact for you about conduction. Have you ever noticed that metals tend to feel cold? Believe it or not, they are not colder. They only feel colder because they conduct heat away from your hand. You just perceive that the heat is leaving your hand as cold. Hi, I'm Mackenzie, and today I'm going to be talking about the concept of our pan we will be cooking our delicious brownies in. So glass pans, for example, and this is a glass pan, it's a Pyrex pan, are made up of substances called silica or SiO2. Silica has a melting point of 2,000 degrees Celsius or 3,600 degrees Fahrenheit. Soda, which is also known as sodium carbonate, is added, which lowers the melting point to 1,000 degrees Celsius. The problem with adding sodium carbonate to silica is that it makes the glass water soluble. So a fun fact is, to fix this problem, lime or calcium oxide is added to restore insolubility.
And another interesting fact is that 90% of glass manufactured today is soda-lime glass. Glass pans are used because they are easy to clean and conduct heat very well. Glass pans are made to have smooth surfaces, but oftentimes need to be oiled to become non-stick. Glass has a specific heat of 0.84, which means glass heats up faster, but also cools down faster.
Come on. Hot, sicker than your average. Pop a twist cabbage off instinct. Niggas don't think shit stink. Pink Gators, my Detroit players. Tim's for my hooligans in Brooklyn. That's dead right. If the head right, Biggie there, and night. Papa been smooth since days of under.
And after 40 minutes or so, take the brownies out and check if they're done. And these are done, so thank you so much for watching our Cooking with Einstein, and have a great rest of your day.